In this video, let's continue our discussion of concrete corrosion and other defects associated with poor concreting. Spalling. Spalling can occur over time when there is an increased ratio of cement to water, which causes more internal vibration. This depression results from a section of the surface concrete separating and the topping, popping, or peeling off. It could also be due to the rebar corrosion, generally due to the insufficient cover while rebar erection. As we have covered this in the section on rebar erection errors already, several case studies clearly demonstrate the significance of meeting the adequate high quality covers. These covers also termed as protective cushion blocks. The problem occurs when these reinforced covers are displaced or inadequate or too little or leakage during concrete grouting. Before work begins, designers and contractors should think about the possible effects of spalling concrete and the falling debris that follows. Pre-pour reinforcement inspection should be taken into consideration to lower the risk of failure. Appropriate reinforcement detailing and quality installation, leveraging appropriate reinforcement support, and ensuring appropriate reinforcement cover and production are crucial for the prevention and mitigation of many of the issues. The other possible reasons of spalling are overworking of the concrete, low entrainment, inappropriate design mix, that is improper water cement ratio such as excessive water or cement, and freeze-thaw cycling. Other major concrete issues: honeycombing. On the surface, coarse aggregate without any mortar covering or enclosing the aggregate particles are known as honeycombs. In general, honeycombing occurs due to an inappropriate design mix with more gravel and less mortar that creates void between gravel that eventually lead to loosening of concrete. Let's look at the possible causes of honeycombing. Incorrect mix ratio, improper water cement ratio, such as too much or too little water in the cement ratio, incorrect aggregate grading, excess aggregates, issues related to formwork such as inadequate cover. We have already spoken about how important cover is. Gaps in the formwork. This usually happens with wooden formwork. Excessive reinforcement. Improper workability. Poor supervision of concrete workability during mixing. Poor vibration management during casting. Improper pouring of the concrete, for example, pouring it too high, inadequate settling time. Blisters. Air bubbles that get trapped beneath the concrete shell surface are known as blisters. Small lumps and other surface flaws result from this. Blisters are typically an indication of poorly mixed concrete. We have to change the mix to remove any defects if we notice blisters during construction. Nevertheless, blisters don't lead to any structural issues with the slab of concrete. Delamination. Similar to blisters, delamination happens when water or air bubbles are trapped beneath the surface of sealed concrete. It's important to allow the concrete to breathe after placing a slab. This lets moisture and air out before we seal the surface. Delaminated areas result from air and water becoming trapped in the absence of this waiting period. Surface scaling. Scaling is one method of concrete deterioration. There will be thin spots when the concrete slab peels apart. The collapse of the surface layer results in a deterioration in the overall strength and integrity of the structure or slab. This could eventually result in more slab problems. Scaling is a common problem on slabs with a poor surface strength and can be caused by blisters, delamination, or a weaker mix. Discoloration. In concrete, discoloration can take the form of blotches, patches, or stains. There is no one cause for discoloration. Discolored patches may result from chemical changes such as cement alkali or admixtures. On the other hand, stains or patches may result from the things like a hard rolled surface, a moist substrate underneath the slab, or a shift in the water to cement ratio at the slab top. Curling. When the moisture content or temperature differential between the slab's top and bottom is too high, concrete curling happens. For instance, the concrete edges will rise and curl if the slab's top dries off too quickly in cold temperatures, while the bottom of the slab rests on warmer, moist ground. For the most part, curling occurs throughout the drying process. This implies that we should identify it and address it before it worsens. Similarly, efflorescence, shrinkage, low spars, pop outs, like many other formation that occurs with concrete surface over the period of time. Addressing these problems before concrete is poured is far simpler and less expensive than doing it after the structure is occupied. We have understood how the design mix play a crucial role in all these effects. So now let's understand what concrete mix and the approval procedure in our next.